my first behind the scenes of Leopard, and as you can tell from the intro, this video is going to be primarily centered around OpenGL and a lot of the graphic support that is behind the scenes of Leopard that give you the wonderful effects that you see on the screen and a lot of the power behind some of the video animation, whether it's 2D, 3D, what have you. The first thing I'm going to start off with is some specs or benchmarks, if you will. One is I'm going to be putting up here right now. This is going to be on Tiger, and this is basically going to show that Tiger has very little support for the higher end specs of OpenGL, like OpenGL 2.1, and you can see that a lot is simply not supported. So now I'm also going to go to Leopard, and I'm going to show you a screenshot from Leopard, the same benchmark utility here, and if I didn't mention the name, it's called GL Viewer, and basically you're going to see that everything has 100% support. So that's the first thing behind the scenes, and to show how much more OpenGL capability and support that Leopard has over Tiger. Alright, so now that we've shown that Leopard supports higher specs of OpenGL, what does all that mean and what does it give us? Well, I'm going to get more technical at this point, and I'm going to start with vertex, frame, and pixel buffers. So everybody's, well, what the heck is that? Well, let's get into it first of all. The old way of doing things, if you can imagine, I'm going to put up a screen right now. Alright, so on the screen we're going to have our CPU, the DRAM, or just normal RAM if you want to, so I don't complicate things, the pipe that's going to transfer the information from the CPU to the GPU, and of course the GPU, the RAM associated with the GPU, and an application that is using OpenGL. Now, if you can imagine, the application is going down, and this goes into the other videos where I was talking about the languages going down into binary, what have you. Well, we're going to go down into the code that instructs OpenGL to, let's say, send a vertex object, and I'll go over what vertex, frame, and pixel objects are. But for now, let's just try to explain the significant difference with Leopard. So we're going to send a vertex instruction. It would normally we'd break it up, and this is a very quick explanation, so bear with me. But we'd break it up, and it'd go over the pipe between the CPU and GPU, and it would go to the vertex processing part of the GPU. Normally, that vertex processing part of the GPU can process the vertex instructions a hell of a lot faster than they can come down that pipe. So you can get lag sometimes, or not. It's not the optimal performance. When we take vertex buffers, specifically with this example, what we're doing in a sense, in very simplistic terms, is caching those instructions on the GPU, or the RAM associated with the GPU, and what that does is it creates a fatter pipe between that RAM and the actual vertex processor within the GPU. So the pipe now is a lot thicker, and the information can be processed a lot faster, and then as we move this information across this pipe between the CPU and GPU, it goes into this buffer cache, and then is able to get processed faster. So it's not, if you will, this vertex processor is like starving for stuff, and we can't feed it stuff fast enough to use its full potential, basically. But in Leopard, using these buffer objects, we can, because we're putting into a cache, and the cache acts like a cache, and then it uses a fatter pipe and is able to send that information to that instruction processor at a rate that the instruction processor can be useful, or a lot faster, let's say, or more efficient. So that basically goes for all the buffers, whether it's vertex, frame, or pixel buffers. This is something that is basically part of the specification of the higher OpenGL standards. Now, let's go ahead and go over what all these buffer objects really are. I'm sure people are like, well, what's a vertex, what's a frame, and what's a pixel buffer? Okay, so a vertex can be defined as points. Basically, a point of a line, a point of a shape, a corner of a polygon, but basically where two edges meet. So I'll show up on the screen here like a simple polygon, and the points there on the edges there are the vertex, or vertices, I should say. Vertexes, however you want to say it. So there's an example of lines and various shapes of what vertices are, and these are instructions that we can basically send through OpenGL and say this is a point, this is a point, this is a point, this is a point, and so on. So let's move on to frame objects. Alright, so the frame buffer object, and I'm going to try to make it as simple as possible, is relatively new in a very powerful and efficient way of rendering, let's say, a texture. And it's not going to be something that you see on the screen right away, but will be brought later. Like, for instance, you're doing, you have a picture, and you want to blur that picture. Well, the frame buffer object can easily just take that normal picture, whatever it is, and then do the manipulation afterwards. Or just, let's say we have a skin texture that we want to apply to a model, and then the model like shows up, and so we can render it off screen, and boom, we can have it show up on a dinosaur. Let's say that the dinosaur is like some sort of chameleon, is changing its skin color from red, smooth to bumpy green, or what have you. So it makes that process much easier and a lot less overhead for doing that. So the pixel buffer, I'll try to make a simple example and just use pixel shaders. And pixel shaders basically help bring the fine detail to a chair, making it look more like leather, or skin, making it more lifelike, so on and so forth. The pixel instructions can then use a pixel buffer object to make that whole process more efficient. So I've covered basically the three main buffer objects that have been introduced to Leopard, and will make the OpenGL experience, or anything that uses OpenGL experience, all that much more powerful, efficient, and faster.